Hello students. So in the previous class we were talking about that of the Bohr's model of atom. In a Bohr's model of atom, students, we discussed that how Bohr has given some postulate, how he explained his model of atom and how he overcome with the drawback of that of the Rutherford model of atom. Okay, so ultimately you can say, student, that he explained the stability of that. So when we talk about the Bohr's model of atom, it explained the stability of the atom. That was not explained by that of the Rutherford model of atom. So if we recall that of the Bohr model of atom, that what are the different postulates of that of the Bohr model of atom, student. So the first postulate of the Bohr model of atom was that atom, it consisting of a positively heavy charged particle that is known as a nucleus, and this nucleus is surrounded by the negatively charged particles that is known as electron. Okay, so in an atom also, this one is also described by that of the Rutherford. He explained that an atom, it consisting of a positively charged particle and which is present, which is concentrated at the center of the atom. So that we call as a nucleus, and around this positive charged particle, negatively charged electron revolves around it. The second thing he explained, he explains that these electrons are revolving around that of the nucleus, but it always revolves in the orbits. Okay, it means we can say that nucleus is having different orbits around it. This different orbits, this circular orbit which is present around that of the nucleus is having a definite energy. Okay, so these orbits, they are having the definite energy, and since it is having the definite energy, we can call it a energy shell or energy level. Okay, so all these circular orbit which is present around that of the nucleus consisting of a certain amount of energy, and that is why we call it a energy shell or energy level. Now these energy shell energy level is given number. We have divided into different number and we have given a name to the different shells, which includes the K, L, M, N. So KLMN is what? It is actually, we are talking about the energy shells, energy level which is present around that of the atom. Remember that, student, there is a very important role of these energy shells when we talk about the electronic configuration or when we distribute that of the electron. So just that you should understand that the energy shells are basically divided into K, L, M, N, and this K shell is having a energy, it is having a fixed energy, N is having a fixed energy, M is having a fixed energy, N is having a fixed energy. So suppose if I say K is having E1 energy, so L will have a E2 energy, and M will have E3 energy, N will have a E4 energy. Okay, so the energies are fixed of these shells, and that is why we call it a energy shell or energy level. Next, students, the electron, if it is present in a certain orbit, what we have studied in the Rutherford, that when it used to rotate, when it used to move around the nucleus, when an electron, it moves around that of the nucleus, student, what will happen? It will start losing the energy in the form of a radiation, that is electromagnetic radiation. Okay, but here if you see, then these electrons are basically present in the certain orbit. Okay, so if it is present here in this certain orbit, in the first orbit, so it will used to rotate around the nucleus in the first orbit. okay, in the K shell orbit, and here it will not going to lose energy or gain energy. So there will be no loss or gain of energy when electron revolve around that of the energy shell or energy level. Why is this so, student? It is because these energy shells, these energy level, they are having a fixed energy, definite energy or fixed energy. Okay, and since it is having the fixed energy, we use another term for it, and that is stationary orbit. So these orbits are also known as stationary orbit since the energy is fixed here. Okay, so energy is fixed here. Now you see here, student, the electron which is having the minimum energy, it will be where? It will be present at the shell which is near to that of the nucleus. This you should remember because it is very important when we will understand the concept of the electronic configuration. That the electron which is having the minimum energy, it will be present in that particular energy shell which will have the minimum energy. Okay, which will be very close to that of the nucleus. Now you see here, students, out of all these, if we talk about energy shell, so I am making here up to L shell. Okay, this is the K shell, this is the L shell, and this is the M. Up to M. Okay. So if an electron is there which is having the less energy, it will be present at the near to that of the K shell. Okay. Why is this so? Because K is the shell which is near to that of the nucleus. Okay. So it will be present at the K shell. Okay. After that, if suppose this electron is having more energy, or any electron is having more energy than that of the K shell, so it will be not present in the K shell, but it will be present at that of the L shell. If an electron is having much more energy, then it will go to that of the M shell, and again it will have the more energy, then it will be present in that of the N shell. So basically the energy of the electron decide that in which shell it will rotate. Okay. Now you see here, student, if suppose electron is there and electron is present at that of the K shell. If an electron is there and this electron is having the energy by which it will be present in that of a K shell. Now suppose the energy present in the K shell is E1, in L is E2, and here it is E3. Okay, so if K shell, if it is having E1, it means the electron which is present in that of the K shell is having the energy equals to E1, and that is why it is rotating in this shell. Okay, now what will happen? You have given energy to it, and external source provided the energy to this electron. So it absorbs energy. Now the energy got increased. Okay, so before that, if it was E1, it absorbs the energy and it will become E2. Okay, and as it becomes E2, what will happen? It will jump to this orbit and it will be starts rotating in that of the L shell. This state is known as the excited state. So we can say that excited state is a state when electron it absorbs the energy. So when electron absorbs energy, it will jumps to the next energy level. That state is known as excited state. Okay, Now as it becomes excited state student, this state, if an electron is in excited state, remember that this state is an unstable state. Okay, so it is an unstable state, so all the atoms want to be stable, all the electrons want to be stable student. So to gain stability, what it will do, again it will lose the energy. Okay, before that student, it gains energy. Here indication, that's why it jumps to the eggshell. Here it will lose energy and finally again it goes back to its original shell, and that state is known as a ground state. Okay, this state is known as the ground state. So a state in which the electrons used to revolve, that is the ground state, and when it absorbs the energy and jump to the higher level, then that state will be the excited state. None of the electron will be present at excited state for a longer period, so it will lose its energy and finally jump back to its ground state or to its original orbit. Okay, from where it has jumped to the excited level. Okay, so this is what about that of the Niels model of atom. So by taking it, by considering all these things, we are able now to we are able to distinguish or we are able to distribute the electrons in the different orbits or in the orbit of the atom. So by this students, we came to know that the electrons, they used to revolve around the orbit. Now in an orbit student, if this is a positive, is this the nucleus? So in the orbit, different electrons are present at the different energy shells. Okay, so if these different shells are given there, so we can say that in a different shells of the atom, different electrons are present. So by this we can define the arrangement of that of the electron in the shells, and that is the arrangement of electron in different energy shells is known as electronic configuration of the atom. So what is the electronic configuration of the atom student? That is the distribution of the electrons or arrangement of the electron in the different energy shell is that of the electronic configuration of the atom. Okay, so now we will discuss that how can we distribute the electrons in the different orbit, or we can say that how the electrons are present in the different energy shell states. So you see here, when we talk about the distribution, there are certain rules which we have to follow to understand the electronic configuration of the atom or to understand the distribution of the electron in the different energy shell. And these set of rules is given by Bury and Bohr. Okay, so Neil Bohr and that of J.B. Bury. This distribution, this set of rules is also known as Bohr and Bury's key. Okay, so basically we talk about the rules which we have to follow while we are distributing the electrons, while we are arranging the electrons in the different energy level. Okay, so the set of the rules is given by Bury and Neil actually goes. Now what are the different rules, students, which is given by them? The first rule, the rules for distribution. The first rule is the electron always enter into the lowest energy level. Okay, so first of all, whenever the electrons, when you arrange the electron, when you distribute the electron at first it will enters into that energy level which one is having the lowest energy. So first one we will write it. The electron fills up the lowest energy first. Okay, so whenever you will distribute the electron, they will start with that of the energy level which is having the lowest energy. And which energy level is having the lowest energy, students? It is the K shell. So K shell is having the minimum energy. So we can say that the filling of the electron will be started from that of the K shell and then it will move to the energy level which is to the energy shells which is having the higher energy than that of the other energy shells. The second one is the filling of the electron must follow a formula which is given by the 2n square. It means we can say the maximum number of electrons accommodated by each of the orbit is given by the formula that is 2n square. Let me tell you that what is 2n square, students. So first of all we will write it. The maximum number of electrons possessed by the orbit must follow the given formula that is 2n squared. Okay, so in the first one we say that the electron must enter into the energy shell which is having the minimum energy. Okay, now electrons enter into the K shell. Now, how much electrons can be accommodated by that of the K shell, students? How we will decide? Okay, that maximum electrons accommodated by that of the orbit will be what? So that will follow a formula and that formula is the 2n square. What is the 2n square, students? So n is the shell. Okay, so first cell, second cell, third cell or fourth cell. We can say the maximum number of electrons. We can understand it. When we talk about that of the n, so n is the orbit. Okay, so we can say formula is maximum number of electron will be equals to 2n square. This is the formula, student. Now, by putting the values, we can find the maximum number of electron possessed by the different orbits which is present around that of the nucleus. Okay, so this is the formula, that is 2n square, and I told you the orbit. Okay, the orbit or the energy shell which we are talking about. Okay, now you see here, if we talk about the first orbit, students, so what is the first orbit? First orbit which is present near to the nucleus, and that energy shell or that orbit is the K shell. Okay. So K shell is what? It is near to that of the nucleus. So we can say that this is the first orbit. So for K shell, n will be equals to 1. Okay, because this is the first orbit, students, so n will be equals to 1. Now, if suppose we will put the value of n in the formula to get the maximum number of electron accommodated by that of the K shell, it will be maximum number of electron by K shell. That will be equals to 2n square. What is the value of n here, student? So, value of n is 1. So, we will write it 2 into 1 the square, and that will be equals to 2. Now, you see here, the maximum number of electron accommodated by that of the K shell, which is the first orbit, is 2. It can accommodate only 2 electrons, not more than that. Remember that. Whenever the electron enters into the K shell, after 2 electrons, no electron will going to enter in the K shell, but it will start going in that of the L shell. Okay, so you see here, student, in the first one we said that it will enter into the energy shell which is having the minimum energy. As it enters into the minimum energy shell, that is the K shell, which is the first orbit near to the nucleus. So we will put the value that is equals to n is equals to 1, and this n is equals to 1 will gives the maximum number of electron accommodated by that of the K shell, students. Now, if we talk about that of the second shell, so the second shell is the L shell. Okay, so this is the L shell, so we will talk about that of the L shell. So this is the second orbit, so we will write n is equals to 2. Now, the maximum number of electrons which is possessed by that of the L shell, student, it will be equals to again the same formula, and that is 2n square. Okay, so if it is 2n square, n it will be 2. So we will write here n is 2. So 2 into 2 to the power whole square, and this will give the value that is 8. Okay, so maximum number of electron which is possessed by that of the L shell, which can be accommodated by that of the L shell, is 8. So L can accommodate only the 8 electrons. So after completing the first shell, that is the K shell, when the electrons start entering into the L shell, as the L shell will complete with the 8 electrons, the number of the electron will then not enter into that of the L shell, but it will start going into that of the N shell. Okay, so after L shell, it is having the maximum number of electrons, that is 8. Then we will talk about the next orbit, student, and the next orbit is the M shell. M shell, so the orbit number is 3. Okay, so because this is the third orbit, so orbit number is 3, so maximum number of electron possessed by that of the M shell, it will be equals to 2 into 3 the power whole square. 3, that is n is the number of the orbit. Okay, so that will be equals to 18. Okay, so we can say that M shell can accommodate the 18 electron. Okay, more than that it cannot accommodate the electron. Now at last we will talk the fourth shell, fourth orbit, and that is the N shell. Okay, so now we will talk about the N shell. So N shell, this is the fourth shell, fourth orbit. So we will write here 4. N will be equals to 4 here. So maximum number of electron possessed by that of the N shell, it will be equals to 2 into 4 the power whole square. and that will be equals to 32. So maximum number of electron passes by that of the n shell, it will be equals to 32. Okay, now you see here student, at first when we talk about that of the K shell, so K shell can accommodate the maximum number of electron, that is 2. When we talk about that of the L shell students, so L shell can accommodate the maximum number, that is 8. When we talk about the M, so M can accommodate maximum number, that is 18, and finally the N shell will have the maximum number of electron, that is 32. So K shell 2, L shell 8, M shell 18, N shell 32. So this much number of electron can be accommodated by that of the different shells. Now when we talk about the third rule for the distribution, although you can see here that these shells used to accommodate this much electron, but when you go to the third rule, which is given by that of the Bohr and Bury, is that no orbit or the maximum number of electrons. So the third one is the outermost orbit of a stable atom, students. The outermost orbit of a stable atom must consisting of a 8 electron, not more than that of the 8 electron. So if we talk about the stable atom, students, so a stable atom in its outermost shell must have a 8 electron, not more than that of the 8 electron. So we can say the outermost orbit of a stable atom consisting of maximum 8 electrons. Okay, so the outermost orbit of a stable atom must have a 8 electron in its outermost shell. Now you can see here, student, although if suppose we talk about the L shell, so L shell is consisting of a 8 electrons. So for that it is okay. But what about the M shell, student? M shell can accommodate 18 electrons. But when we talk about the stable atom, its outermost orbit, even though if it is an M shell, must have a 8 electron only. So maximum it can accommodate, if a stable atom is there, so outermost shell must have a maximum 8 electron, even though the formula even is showing that it can accommodate more than that. But the stable atom must consisting of a maximum 8 number of electrons in the outermost shell. Okay, so these are the different set of rules for the distribution of the energy, distribution of the electron in the energy shells. Now you see here, first one what we say, student. So first rule that an electron always enters into the lowest energy shell. Energy shell which is near to the nucleus is having the minimum energy, like that in the K shell, students. So K shell is having the lowest energy. So electron will first enter into the K shell. Okay, so because it is having the minimum energy, so it will start filling the energy level, energy shell which is having the minimum energy, and then it will start moving to the energy shell which is having the more energy. Okay, which is having the maximum energy. Okay, the second one, that the electrons which is accommodated by that of a different orbit, including the K and L orbits, they follow a formula, and that is given by 2n squared. So maximum number of electron passes by the different orbit is the K shell. When we use the formula, we find that K shell can accommodate 2 electrons in it. If we talk about that of the L shell, students, so L shell, it can accommodate the 8 electrons. can accommodate 18 electrons. N shell, it can accommodate 32 electrons. So these are the maximum number of electrons accommodated by the different orbits. Then the third one. Third one said that okay, if the orbit is able to accommodate a more number of electron than that of the 8. Okay, up to 8 electron it is okay, but when we talk about the M and N, it can accommodate the number of electron more than an 8. But the third rule says that if an atom is stable, its outermost orbit, outermost shell must have a maximum number of 8 electrons in it, not more than 8 electrons. Okay, so if an M shell is there also, the M shell must have 8 electrons to provide the stability to the atom. So if it is a stable atom, it must be consisting of 8 electron in its outermost shell. 8 electrons, we use the other term for it, that octet. Okay, so it must, the outermost shell must have its octet student. Must have its octet, it means must have 8 electrons in it. So these are the different rules which is given by the Bohr and Bury. Most of the time question will be asked that what are the rules which is given by Bohr and Bury, or what is Bohr and Bury's scheme students. So don't get confused. You have to write the rules which was given by them. Okay, you have to explain the rules. And not only this, right after that we will discuss about the examples also. So whenever the question is asked, you have to explain it with the help of the example. Okay, it totally depends upon the number of the marks also. If it is of more marks, of 5 marks, then you have to draw the diagram. You have to draw the different shell and explain the each and every points given by that of the Bohr and Bury. So we will discuss about that of the different examples with the help of this formula, so that you will understand the formula very well.